Hi, everybody. So I'm going to talk a little bit about input switches now. Input switches. So in the lab, you've been using the green logic boards, and you've been connecting to their switches. And something that we've learned in the course lab, and we talked about this a little bit in the lab, but was this idea, and I'll use an inverter gate as my example gate, was the idea that this input here should not be left floating. So you should either tie it high to 5 volts, or you should tie it low to ground. And obviously you wouldn't do both of those things at the same time, right? But you don't want to leave it dangling. That's the idea, right? If you leave it dangling, it's picking up noise, and you don't know, you don't have a guaranteed output. You don't know what your output is going to be, right? But if you were just using a wire and you're switching between high and low, there is always this in-between state where you're moving the wire, and then you don't know what the input is for that in-between state, or you're picking up this noise that is giving you little glitchy things, or actually changing what you want your circuit to do in this in-between state. So you want to avoid that in-between state. So what we're going to look at right now is how to connect to input switches so that that sort of thing doesn't happen. And right now I've got option 1, right? So let's look at option 1. And I'm going to tell you right away, it's not a good option. Okay, it's not a good option. And option 1 is to just have this, the input to this inverter, have it just tied right to this switch. So it's going to the switch, and the switch is going to 5 volts. If I close the switch, I get 5 volts. So with the switch closed, the input is 5 volts, and that's good. But with the switch open, the input is floating, and that's bad. Okay, so so we don't want that. So we're going to go to option 2. Okay, and so option 2, and I'll tell you right from the start, option 2 is also not a good option. Okay, so keep that in mind. Option 2 is also not a good option. And to make that very clear, we're going to say we're not going to do option 1. And we're also not going to do option 2, but let's look at first why. So here I've got my switch again, wired to the input of my gate, but I'm going to also tie the input of my gate to ground and the switch to 5 volts. So if I do it this way, with the switch open, the input is low because it's tied to ground, and that's good. But with the switch closed, I have tied 5 volts to ground, which is shorting the supply, which is very bad, right? So that is totally bad. And that's why we are actually also not going to do option 2. So we have to look at, okay, what can we do? And there's 2 options that we can use here that can work out nicely. So let's look at option 3. And option 3 is with a pull-down resistor. So what I would do, I still have my gate and the input. Now, I'm still connecting my gate to the switch. Instead of going directly to ground from this, this gate side, I'm going to go through a resistor to ground, and then the other side of the switch is still connected to 5 volts. This is some resistance. If I do this, With the switch open, if I've sized this resistor correctly, I still have a low input, so that's good. And with the switch closed, I have 5 volts to the gate input, and I have the resistor as load, so the supply is protected. So that's good, right? So this is a good option, right, with a pull down resistor. Now the other thing I can do is I could do a pull up resistor instead of a pull down. So option 4, with a pull up resistor, and you'll see the difference. Note that the pull down resistor here, when the switch is open, you get a low input. With the pull up resistor, it's the opposite. With the switch open, you are going to get a high input. So the other end of the switch is in fact grounded, and it's the gate side of the connection that goes to 5 volts. So with the switch open, the input is still high if you've sized that resistor R correctly, and of course we will. This is with switch open. And with the switch closed, the input is low because now the input's connected directly to ground through the switch. But the supply is protected by the resistor R. So we're not shorting the supply. Okay, so we've got these 2 options. Both are good, option 3, option 4, for a pull down resistor or a pull up resistor as a way to connect our switches so that when the switch is open, the input's not floating. It is actually connected high or low, and when we close the switch, we get the opposite state. At the same time, the supply is connected.